The auxiliary power unit, or APU, is a gas turbine enclosed in a shroud, located in the forward section of the main wheel wells. Compressor and cooling air is drawn from the left wheel well. Cooling air is routed through a cooling air inlet door around the APU and combined with APU exhaust. Exhaust is ducted from the right wheel well through fixed louvers in the upper inboard surface of the right wing. The APU provides bleed air and electrical power and is restricted to ground operation only. The APU generator is directly coupled to the APU and rotates when the APU is operating. The voltage regulator on the generator automatically produces the proper voltage. APU bleed air may be used for air conditioning or engine start. Since APU pneumatic output is not adequate to operate both air conditioning packs, a flow multiplier is utilized when APU bleed air is used for dual pack operation. The flow multiplier operates to augment pneumatic air from the APU. During single pack operation, the flow multiplier is bypassed. An overheat sensor detects for excessive temperature in the flow multiplier. The cockpit controls and indicators are located on the second officer's auxiliary panel and the second officer's upper and lower panels. An APU remote ground control panel is located in the left main wheel well. Prior to APU start, the following switch positions should be selected. The Engine 2 APU bleeds closed, battery on, DC meters to battery, essential power to any position other than APU, AC meters to APU, bus ties closed, and the APU field closed. An APU start is initiated by positioning the APU master switch to on, which opens the APU fuel shutoff valve and illuminates the generator breaker light. Illumination of the APU light occurs only when starting the APU while the aircraft is already electrically powered. Momentarily holding the master switch to start allows the aircraft battery to energize the APU starter motor and begins the automatic start sequence. Starter engagement is confirmed by illumination of the APU crank light and a full-scale discharge on the DC amp meter. Confirm that battery voltage is 18 or higher. A rise in EGT should occur within 15 seconds of crank light illumination. Within 30 seconds of initial EGT rise, the crank light should extinguish and EGT should stabilize in the green band. The DC amp meter then returns to normal. The DC amp meter should display a positive indication after each APU start once the aircraft is electrically powered. This confirms an operative battery charger. After the APU is started, the aircraft electrical load may be applied provided EGT, volts, and frequencies are stabilized. Indications of volts and frequencies may take up to 1 minute after starter cutout. Closing the APU generator breaker connects the APU generator output to the aircraft synchronizing bus. The AC amp meter indicates APU generator load when the APU generator is connected to the synchronizing bus. The AC amp meter load should be less than 165 amps. Move the essential power selector to APU and confirm the essential power failure and master warning lights are extinguished. The APU should run 1 minute with the bleed switches off after starting and before shutdown. APU bleed air is controlled by the engine 2 APU bleed switches. Selecting either switch to open supplies APU bleed air to the pneumatic system. Should any of the following conditions occur, the APU fire switch should be pulled to abort the start. No EGT indication within 15 seconds of crank light illumination, EGT rapidly rising towards the red radial, APU crank light does not extinguish within 30 seconds after EGT indication, frequency does not stabilize, EGT stabilizes in the yellow band when the APU is under no pneumatic load, or APU torching is observed. If low oil pressure, overspeed, or an APU fire is sensed, the APU shuts down automatically. A flow multiplier overheat is indicated by illumination of the APU bleed light and automatic closure of the APU bleed valve. Once the overheat detector is cooled, turning the APU engine 2 bleed switches to off resets the APU bleed trip. The APU is equipped with fire detection and protection. An APU fire detector element is located in the APU shroud and is powered by the battery bus. Should the element become heated, fire warnings are initiated. Fire extinguishing is accomplished by a fire bottle located in the left wheel well. The bottle has a direct pressure reading gauge and is connected to a thermal discharge line. If the bottle vents due to overpressure, a red thermal discharge disc under the left wing will blow out. To perform an APU fire test, ensure that the battery switch is on, the APU fire switch is in, and the auto fire shutdown switch is armed if the APU is not operating. Holding the fire warning test reset switch to the test position heats the detector element to simulate an APU fire. Test time is limited to 60 seconds. In the cockpit, the APU fire warning bell sounds, and the APU fire warning light illuminates. Positioning the fire warning test reset switch momentarily to reset silences the fire warning bell. When the element has cooled, the fire warning light extinguishes. Once this occurs, a second reset restores the APU automatic start circuit and allows for an APU start. Should the APU fire detector element become heated, the APU fire switch illuminates and the warning bell in the cockpit sounds. Outside the aircraft, the remote fire warning light flashes and an intermittent horn in the nose wheel well sounds. If a fire is sensed with the auto fire shutdown switch armed, the fuel shutoff valve is automatically closed. Momentarily positioning the fire warning test reset switch to reset silences the fire bell, the nose wheel well horn, and changes the external flashing red light to steady. Pulling the APU fire switch arms the fire bottle discharge switch, interrupts the automatic start sequence, trips the APU generator field, closes the APU bleed valve, and closes the fuel shutoff valve if not previously closed by the auto fire shutdown feature. With the fire switch pulled, The extinguished APU light is a positive indication the fuel shutoff valve has closed. The light remains illuminated until the detector element cools.